Now we're going to look at some kind of physics type problems with vectors and force. And the big thing to know is that when in a word problem, when they talk about force, that's the same thing as our magnitude. Okay? So we have a worker pushing a wheelbarrow with a force of 25 newtons downward. Newtons is just a measure for force. The angle the handle makes with the horizontal is 36 degrees. They've already given it to us. They want us to write that force vector. So the first thing that I want to be sure we see is right here where this guy is holding it is kind of where our axis would be, right? So that means that this vector occurs in the third quadrant, right? Yep. So if this guy's in quadrant 3, we know that it's negative, negative, right? That force is down and over. But the angle they gave me is acute, right? Because what they gave me was theta hat. So we've got to be careful here. We have two options. Let's see, I'm going to call this theta hat. So we have the reference angle. We can do two different things. We can use the 36 degrees in our magnitude cosine, magnitude sine, and just know that it has to be negative, negative because it's in the third quadrant. Or we can find the full theta, right, by doing 180 plus 36 and then put that angle in. It doesn't matter. If we want to do the fewest steps possible, right, I would just say, okay, this is going to be negative because the horizontal is negative here. The force is what, 25? Cosine 36 minus, minus 25 sine 36J. So 25 cosine 36 is going to give me negative 20.23I minus 25 sine 36, 14.69. But realize when I put the cosine 36 and the sine 36 in my calculator, I'm getting positive, positive for those, right? Because I'm getting the first quadrant guy, so I just have to know that they're negative. Again, your other option would be to add 36 to 180 to get your full theta and use that for your sine and cosine. Same type of thing here. So we have the force he's pulling. And so here is our axis, right? So this guy is in quadrant 2, and in quadrant 2 we are negative, positive, right? And again, that 44 is the reference angle, right? So that's like pretending it's in the first quadrant. Using that, we would get positive, positive, so we'll just tack it on the end, right, the sign. So we know that the force is going to be negative 60 cosine 44I plus 60 sine 44J. 60 cosine 44 is that negative 43.16I. And again, I'm putting that negative there. 60 sine 44, 41.68J. So again, your options are to use the 44 and know that it's negative, positive, or find your true theta, which is the 180 minus 44, and use that angle.